In today's video, I would like to introduce a very nice problem of Italian Mathematical Olympiad edition 1995. Here is the following setup. Find all pairs of positive integers such that here is the following equation: x squared plus 615 equals 2 to the y as a power of 2. In fact, this is a very straightforward equation, so I would recommend to give it a try to this problem prior getting to the solution. By the way, don't forget to support us with your like and subscribe. Now let's go ahead, jump into the solution. But before I proceed with the solution, we are going to break this one into two cases. So the case number one, y is odd. I'm going to remind you about a very important thing here. I'm going to reduce n squared mod 3 when you have a perfect square. In general, for n squared, you have 0 square is a congruent to 0 mod 3. We have 1 square is a congruent to 1 mod 3. I'm reducing this one to mod 3. So we have 2 square is a congruent to 1 mod 3. And check to the next one. 3 square. 3 square is 9. 9 is 0 mod 3. Because 3 divides 9. For the next case, 4 square is a congruent to 16. 16 is 1 more 15, which is 1 mod 3. Is a congruent to 1 mod 3. So for 5 square, which is 25, 25 is 1 more 24, which is a congruent to 1 mod 3. For the next one, 6 square is the same as 36. 36 is 0 mod 3 because 3 divides 36. 0 mod 3. So if you take a look carefully here, for n square we have only 0 and 1 are congruent to mod 3. So for n square is always we have 0 or 1 mod 3 as a perfect square. That means n square is a congruent to 0 mod 3. Okay, I'm going to add number 1 on both sides. So I will have n square plus number 1 is a congruent to 1 mod 3. This one is telling us 3 not divide n square plus number 1. Okay, I'm going to keep this one for later. For the case number 1, y is odd. We assume x and y is a solution. Now I'm going to reduce this equation to mod 3. So we have 2 to the y is a congruent to minus 1 to the y. Since y is odd, this minus 1 towards minus 1. Minus 1 mod 3. This is one side. The other side, I'm going to reduce the left hand side of this equation to mod 3 as well. So we'll have x squared plus 615 equals x squared. 615 is the same as 3 is multiplied by 205. If I'm going to reduce this one to mod 3, this one goes to the 0. I will have x squared is a congruent to x squared mod 3. Going to match right hand side and left hand side of this equation. So we have equality. 2 to the y equals to this one. So this one is telling us x squared is a congruent to minus 1 mod 3. Because we have equality. Okay. By taking minus 1 to the left hand side of this equation, we'll get x squared plus number 1 is a congruent to 0 mod 3. This one is telling us 3 divide x squared plus 1, which is contradiction, which is impossible, because we already proven 3 not divides x squared plus 1 based on this proof. Okay, so that means we have no solutions when we have y as an odd number. No solutions. No solutions because of this contradiction. Now let's move on to the next case when we have y is an even number. Now in this case, when we have y is an even, let's set y equals 2n. Because y is an even, I'm going to replace this fact into y to see what's given us. I will have x squared plus 615 equals 2 to the 2n. 2 to the 2n by taking x squared to the right hand side of this equation, I will get 615 equals 2 to the n squared minus x squared. This one is written on the form of the difference of two squares. I'm going to factor out this one, so I will have this one will have 2n minus x factor 2n plus x. 615 is the same as 1 is multiplied by 615 is also is 3 is multiplied by 5 is multiplied by 41. Now we'll have too many cases. Case number 1, as we know, since we have positive integers, that means this term is always bigger than this term. That means this term is taking the smaller number, this term is taking the bigger number. So for the case number 1, I will have 2 to the n minus x is taking the first possibility, number 1. This one is taking the maximum number. We will take 2 to the n plus x equals 615. For the second case, case number 2, we will have 2 to the n minus x. This time is taking number 3 as a small number. For 2 to the n plus x is taking 5 is multiplied by 41 is the same as 205. For the third case, case number 3, I will have 2 to the n minus x is taking number 5 this time, but 2 to the n plus x is taking 3 is multiplied by 41, which is 123. For the case number 4, for the last possibility, I will have 2 to the n minus x. This time is taking number 15. 3 is multiplied by 5. For the 2 to the n plus x is taking 41. So now I'm going to go through each one. For this one, I'm going to eliminate 2 to the n first by subtracting this equation from this equation. I will get 2x 615 minus 1, which is 614. It's equivalent x equals 307. X equals 307. That's mean 2 to the n equals 1 plus x, because I'm taking this minus x to the right hand side of this equation, which is I get 307 plus 1, which is 308. 308 is not the power of 2, okay? It's not written on this form of 2 to the n. So that's mean this one is rolled out of this possibility. This one is not, doesn't work. Let's check the second case. I'm going to do the same thing by subtracting this one from this one. I will get 2x 205 minus 3 is giving us 202, equivalent x equals 101. X equals 101. That's mean 2 to the n equals 3 plus x. 3 plus x, that's mean 101 plus 3, which is 104. 104 is not the power of 2 as well, so that's mean is ruled out of this possibility. Let's check the third case. The third case, by doing the same job, by this one minus this one is giving us 2x 123 minus 5, which is 118. This one equivalent x equals 59. 59, that's mean 2 to the n equals x plus 5. 59 plus 5, which is 64. 64 is the same as 2 to the 6. Okay, now this one is a power of 2, is written on the form 2 to the n. Now we found n equals 6. I have a solution for this one. Let's check the last case. Last case, it seems not the solution. By doing this one minus this one, we will get 2x equals 41 minus 15, which is 26. 26 the same as x, equivalent x equals 13. X equals 13, that's mean 2 to the n equals x plus 15, which is 28. 28 is not the power of 2. That's mean this one is rolled out of the possibility. That's mean y equals to n. That's mean y equals to n equals 6. That's mean y equals 12. Now we found the solution y equals 12, a pair of the solution. Now we found x equals 59 as a pair of the solution, and y equals 12. So the only solution that we found for this one. Now we have done with this problem. If you are interested in this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.